Good morning, students. This is topic 15, video B. Let's practice number 2. A compound contains carbon, sulfur, and chlorine. The compound is 10.4% carbon and 27.8% sulfur. What is its empirical formula? And number 2, if a compound with molar mass 84 grams per mole has the empirical formula CH2, how many atoms are in one molecule of this compound? Now let's dive a little deeper into the two solutions. So here is our first problem. To start, we want to find what percentage in the compound chlorine is. We already know carbon and we know sulfur. In order to do that, we just take 100 minus 10.4 for carbon plus 27.8 for sulfur, and that equals 61.8% chlorine. We need to find the molecular weight of carbon. Looking at the periodic table, we see it equals 12.01 grams per mole. We have 27.8% sulfur. The molecular weight of sulfur is 32.06 grams per mole. And we have 61.8% chlorine. The molecular weight of chlorine is 35.45 grams per mole. Now we are going to equate the percentages of each compound to the number of grams. We're going to say that there are 10.4 grams of carbon in the compound. We're going to say that there are 27.8 grams of sulfur and 61.8 grams of chlorine. Now, we want to convert these grams to moles using the molecular weights of each element. We're going to use dimensional analysis. Grams per mole. And the number of moles, there's 1 mole in 12.01 grams per mole of carbon, which equals 0.866 moles. And now we'll do the same thing with sulfur using dimensional analysis. 1 mole over 32.06 grams per mole, and that equals 0.867 moles. We'll put carbon here, sulfur. Same thing for chlorine. 1 mole over 35.45 grams per mole, and that equals 1.74 moles of chlorine. And there are shortcuts you can take, so you don't have to go through writing out all this math, but I'm just doing it so that it's very clear. The next step in solving for the empirical formula is to find the lowest common denominator. Here in our case, it would be 0.866 moles of carbon, and we divide each one by 0.866 moles of carbon in order to find the empirical formula. So we're going to do that for carbon, 0.866, for sulfur, 0.866, for chlorine, 0.866. Now obviously for carbon, that's going to equal 1. Sulfur, it's going to round and it's going to end up equaling to 1. We're looking for whole numbers here. Chlorine, it's going to actually equal 2.01, but if you round, it's going to be equal to 2. So now we have our subscripts needed to complete our empirical formula. Our empirical formula is going to be equal to CsCl2. And now for our second problem. What we are essentially solving for is the molecular formula, which is the actual whole number atomic mole ratio of compound, as opposed to the empirical formula which we found in the previous problem, which is the simplest whole number mole ratio of atoms within a molecule. We are given the molar mass in this problem, which is 84 grams per mole for CH2. The molecular formula is based on the mole ratio and the total molar mass. CH2, which they have given in this problem, is actually the empirical formula. So first, we need to find the molecular weight of CH2. Using the periodic table, we find 12.01 grams per mole for carbon, plus 2.016 grams per mole for H2, which equals 14.03 grams per mole. In order to find the ratio of the molecular weight to the mass of the empirical formula for CH2 that they've given in the problem, we're going to take 84 grams per mole and divide that by 14.03 grams per mole, which gives us, well, it actually gives us about 5.99, which we then round up to 6. Next in the process, we're going to multiply our empirical formula by this number 6, by this ratio, which gives us C6, H6 times 2, H12. Now the problem asked how many atoms are in one molecule of this compound. So we simply just add up these two subscripts, and that gives us 18 atoms in the compound.